But nature.
Good afternoon, students. So let us start with our today's class. Today we are discussing alternating current. So in this chapter, first we will discuss what all formulas are there. Then we will continue with the class. Okay. Yes. So here we have some of the formulas. You can make a list of that. Okay. Yes. So first we have the root mean square current, that is IRMS. So what is the formula for IRMS? So please make a note of it. Hope so it is visible. So after writing, please don't tell it is not visible. Yes, is it visible to everyone? That is first formula. We have IRMS is equal to I naught divided by root 2. So this is IRMS and the average value, the relation between the currents. The next, similarly, we can write it for VRMS also. So for VRMS, it is given as V naught upon root 2. Yes. Okay. So whatever formulas are there for the current, same way we can write it for the, that is for the potential also. Okay. So, and we have already, about this formula according to Ohm's law. Just ಇದು ಗೊತ್ತಿರಲಿ because somewhere we will use it. Okay, that is I is equal to V divided by R anta baratte. Or else we can also write it as I is equal to V naught sin omega t divided by R. So what is V naught by R? V naught by R, we can write it as I naught sin omega t. So that is the current, the value or the formula for the current when it is applied for the pure resistors, when it is applied for the pure resistor. Okay, I is equal to I naught sin omega t. So similarly, we can write it for V is equal to V naught sin omega t also we can write. This is for the pure resistor. Bekadre ನೀವು ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ಬರೀರಿ. This is for the pure resistor. Similarly, we can apply the formula for the inductor as well as for the that is capacitor also. That is, for the inductor, the formula is given by, that is, I is equal to I naught sine of omega t minus pi divided by 2. Okay, this is for the what? This is for the pure inductor. When the AC circuit consists of the pure inductor, the expression is given by I is equal to I naught sine omega t minus pi divided by 2. But voltage expression ಎರಡರಲ್ಲೂ same ಬರುತ್ತೆ. V is equal to V naught sine omega t. But current expression, we will get it as this one. Okay, so copy down. Then next, when the AC circuit is applied for the pure capacitor, the formula is given by, this is for the inductor, I'll register bardvi, this is for the inductor, and here we are writing it for the capacitor. I is equal to I naught sine omega t plus pi divided by 2. In both the cases, the potential value, the voltage value is same, that is V is equal to V naught sine omega t. But the current value, in case of the pure resistor, it is I naught sine omega t, and for the inductor, it is I naught sine omega t minus pi by 2. But the capacitor, I is equal to I naught sine of omega t plus pi by 2. Okay, the next one. We are writing the next formula, that is inductive reactance and the conductive reactance anta ಎರಡು term ಬರುತ್ತೆ. So that is first one, XC we have, that is capacitive reactance anta ಹೇಳ್ತೀವಿ. So the expression for the capacitive reactance, XC is given by 1 divided by omega into C. This is omega, okay. And the omega value can be written as what? 2 pi f into C. 1 upon omega C or 1 upon 2 pi f C. Similarly, for the capacitive, this is capacitive reactance, capacitor iddaga. Inductive reactance, when the inductor is there, then it is given by XL is equal to omega into L, or we can also write it as what? 2 pi FL. We can write it as 2 pi FL. Okay. So this XL and XC are nothing but the opposition. It is like a resistance only. So simple circuit iddaga nav enanta ಹೇಳ್ತೀವಿ, resistance resistors anta ಹೇಳ್ತೀವಿ. When you have the inductor in the circuit, the opposition offered by the inductor for the flow of current is called as what? That is inductive reactance. But the capacitor iddaga capacitive reactance anta ಹೇಳ್ತೀವಿ. Okay. And suppose if you have all the three, andre inductor, capacitor and the resistor, if you have all the three, what is the expression for current? What is the expression for Z? That all we will write now. Okay, that is called as the LCR circuit anta ಹೇಳ್ತಾರೆ. So when you have the LCR circuit, that time the expression is given by Z is equal to under root of R square plus XL minus XC whole square. R square plus XL minus XC whole square. So this is called as what? Impedance anta heltivi. So Z is nothing but impedance. So nimdu circuit alli when you have all the three, like inductor, capacitor ಮತ್ತೆ resistor, all the three gadgets ಇದ್ದಾಗ the opposition offered for the current is called as what? Impedance ಅಂತ ಹೇಳ್ತೀವಿ. So that is given by Z is equal to. Okay, so suppose question ಅಲ್ಲಿ by chance capacitor ಇರ್ಲಿಲ್ಲ ಅಂತ ಅಂದ್ರೆ the expression is written as Z is equal to under root of R square plus XL square. Suppose inductor ಇರ್ತಿರ್ಲಿಲ್ಲ ಅಂತ ಅಂದ್ರೆ ಆವಾಗ ಏನ್ ಮಾಡ್ತಿದ್ರಿ? Z is equal to under root of R square plus XC square. Okay, so this is how we can write. Then we have the expression for the impedance triangle. So impedance triangle irbekadre, that time the expression is written as phase angle. So alli phase angle anna find out madbekadre tan pi is equal to, we have VL minus VC divided by R. VL minus VC by R, or pi is equal to now adanna tan inverse haki VL minus VC divided by R anta baribodu. Okay. So the same expression can be written for XL also. So that is given by XL minus XC divided by R. XL minus XC divided by R. So power factor anta one barutte. For the power factor, the expression is given by cos pi is equal to R divided by Z anta tagoltivi. Cos pi is equal to R divided by Z. Can anyone tell me what is the expression, what is the unit for the impedance? So Z anna impedance anta helidvi. What is the unit for the impedance? Yes. What is the unit for the impedance? Impedance is nothing but opposition offered for the current when we have the inductor, capacitor and the resistor in the circuit. Resistance the unit en barutte. What is the unit of resistance? Ohm, yes. So when you have ohm, similarly we have ohm for impedance also. Impedance kuda same unit barutte. Okay. Then we have, okay, LC oscillations and all deleted alla. Then last formula you can take, that is for the Q factor. So the Q factor is given by, that is the resonant frequency divided by F2 minus F1. F1 and F2 are the lower frequency and the higher frequency. FR is the resonant frequency, is calculated for the power factor. Okay. So this is the formula for the power factor. Yes. Now what we can do? Now we can go for the numericals. So alle en baratte anta nodta hogana. Ist maximum ist formulas madidre you can write aram say whatever the questions are there. You can attempt it. Okay. So here you can see the first question. Yes. If a capacitor of 8 microfarad, so capacitance value is kotidare, it is given as 8 microfarad connected to a potential of 220 volt, and the frequency is given as what? That is 100 hertz. Frequency is given as what? 100 hertz AC source, and the current passing through it is, so the current passing through it is how much? 65 milliampere. So this is nothing but what? 65 into 10 raised to minus 3 ampere. 65 into 10 raised to minus 3 ampere. Then the RMS voltage across it is, then the RMS voltage across it is. So RMS voltage, VRMS you have to calculate. So VRMS beku anta andre what you need to do? Yes, how you can simplify? VRMS. ನಾನು ನಿಮಗೆ ಫಸ್ಟ್ ಫಾರ್ಮುಲಾಸ್ ಅನ್ನ ಹೇಳಿದೀನಿ. VRMS ಅನ್ನ ಯಾವ ರೀತಿಯಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು? CS students. So here VRMS is calculated because the ಇದೇನ್ circuit ಇದೆ, the circuit is consisting of what? That is the capacitor. Circuit ಏನ್ contain ಮಾಡಿದೆ, that is it consists of the capacitor. ಹೌದಾ? So therefore XC is equal to 1 upon 2 pi F into C ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ, because here The VRMS is given by, it is IRMS into XC because ಇದೇನಿದೆ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕೆಪಾಸಿಟರ್ ಇರೋದ್ರಿಂದ ಯೂಶುವಲಿ ನೋಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಯೂಶುವಲಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ಓಮ್ಸ್ ಲಾ V is equal to IR ಅಂತ ಬರುತ್ತೆ. Okay, so please see here. Don't focus on the solution. First see what I am saying you. That is potential is equal to IR ಅಂತ ಬರಿತೀವಿ ಹೌದಾ. The voltage ಅಥವಾ ಏನಾದ್ರು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ we write it as V is equal to IR. But here the circuit is not containing the resistor. The circuit is consisting of what? That is the capacitor. Therefore the expression becomes what? That is IRMS into XC. IRMS into XC. ಹಾಗಾದ್ರೆ XC ಅನ್ನ ಯಾವ ರೀತಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬಹುದು? XC is equal to 1 upon 2 pi f into C. So that is nothing but 1 divided by 2 into pi value 3.142 into f. Frequency is how much? Frequency is given in the question, that is 100 hertz into C value. So C value is 8 microfarad, that is 8 into 10 raised to minus 6. Yes. So if you simplify this one, so idanna simplify madkondre you are getting it as 199 ohm, that is 199 ohm. So when you get the XC, we can go for the VRMS calculation. So further you can see that the VRMS is equal to what? That is IRMS into XC. So IRMS is nothing but what? That is 65 milliampere anta ide. Therefore 65 into 10 raised to minus 3 into 199. So option B is the correct answer. You can see the solution part there and copy down. Is the next question. Phase difference between voltage and current in a capacitor in an AC circuit is. Yes. So the circuit consisting of what? That is the capacitor. Very simple question. Egaste formula nodidvi. Yes, Tasmiya, correct. It is option B, pi by 2. Hauda. So egaste nodidvi now adanna. The next question, in an alternating current circuit consisting of elements in series, the current increases on increasing the frequency of supply. Which of the following elements are likely to constitute the circuit? In an alternating current circuit consisting of what? Elements in series. Alenide, the current increases on increasing the frequency of supply. So current yav ರೀತಿಯಾಗಿ increase ಆಗ್ತಾ ಇದೆ by increasing the frequency. So ಇದರಲ್ಲಿ ಯಾವುದು true ಇದೆ? Which of the following elements are likely to constitute the circuit? C, that is resistor and capacitor. Yes, very good. So that is resistor and capacitor, because the inductive reactance of capacitor is given by Xc is equal to 1 by omega C. As frequency increases, Xc decreases and therefore current increases. As R does not vary with frequency, therefore likely elements constitute the circuit may be a capacitor and a resistor. The next one is a numerical C. A 30 microfarad capacitor is connected to a 150 volt 60 hertz AC supply. The RMS value of the current in the circuit is. So here you need to calculate IRMS. Yes. So if you have understood the first question, you can simplify this. See. Copy down the question first, then you can try this. Yes. So IRMS is equal to VRMS divided by XC. VRMS is equal to 150 volt. But XC is equal to 1 upon omega C. So 1 upon omega C is nothing but what? 1 upon 2 pi FC. So if you simplify 2 pi FC, you are getting it as what? 88.46. ಹಾಗಾದ್ರೆ IRMS is equal to ಎಷ್ಟಾಗುತ್ತೆ 1.7 ಆಂಪಿಯರ್ ಅಂತ ಆಗುತ್ತೆ. Okay. Yes, option B. Yes, very good. Remaining students ಯಾರಿಗೆ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಪ್ಲೀಸ್ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಳಿ. Yes, next question. Let's take a 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. The RMS value of current in the circuit is, what is the value of the IRMS current value in the circuit? 1.49 ampere, 14.9 ampere, 2.49 ampere to 24.9 ampere. So capacitor is a capacitor circuit. AC circuit consisting of a capacitor. IRMS. IRMS is equal to VRMS divided by C. Yes. Correct. Very good. So like previous question only. Hope so ಎಲ್ರಿಗೂ ಆನ್ಸರ್ ಬಂದಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. No need to simplify this. IRMS is equal to VRMS divided by R. R ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ XC ಆಗತ್ತೆ. So XC you have to find out and keep it. Hope so you will try it. Option C ಬರುತ್ತೆ ನೋಡಿ. Okay. I am going for the next question. Yes. In the question number means the previous question. So E question only. The net power absorbed by the circuit in one complete cycle is. So one complete cycle alli what is the power anta kelidare. What is the power absorbed by the circuit in one complete cycle? 5 volt, 5 watt, 10 watt, 15 watt, 0. Means the circuit is consisting of what? That is capacitor. So capacitor circuit iddaga power ಏನ್ ಬರುತ್ತೆ? D. Yes, what about other students? Yes, it is option D. Very good. So ನಾವು ಇದನ್ನ derive ಕೂಡ ಮಾಡ್ತೀವಿ lesson ಅಲ್ಲಿ. That is power is equal to VRMS IRMS into cos pi. So in the pure capacitance circuit, the phase difference between the alternating voltage and current is pi by 2. So pi by 2 ಇರೋದ್ರಿಂದ cos 90 0 ಆಗತ್ತೆ. Therefore the power value will be 0. Yes, copy down the reason. Moving towards the next question. In which of the following circuit the maximum power dissipation is observed? Pure capacitive circuit, pure inductive circuit, pure resistive circuit, none of this. Yes, in which circuit we can see the maximum power dissipation? Capacitor allantu illa yakandre ನಾವು ಈಗಷ್ಟೇ question ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. That is pure resistive circuit. Other students? Yes, Pavitra, Tasmiya. It is option C. Very good. So power dissipation will be maximum in the pure resistor circuit. So pure resistor circuits only the power will be maximum. Go for the next question. When an AC voltage of 220 volt is applied to the capacitor C, then when an AC voltage of 220 volt is applied to the capacitor C, then ಏನಾಗತ್ತೆ? So AC circuit ಅನ್ನ voltage of 220 volt ಇದನ್ನ ಮಾಡಿದಾಗ connect ಮಾಡಿದಾಗ what will happen here? The maximum voltage between plates is 220 volt. The current is in phase with the applied voltage. The charge on the plates is not in phase with the applied voltage. Power delivered to the capacitor per cycle is 0. Yes, what is your answer? Per cycle is 0. Yes. Okay. So let's see. That is option D is the correct answer because now already discussed ಮಾಡಿದೀವಿ ಇದನ್ನ. Similar one. So here you have the circuit which consists of capacitor ide, inductor ide, resistor ide. You have a LCR circuit. What will be the reading of the voltmeter? So voltmeter reading ಏನ್ ಬರುತ್ತೆ? 300 volt, 900 volt, 200 volt, 400 volt. What will be the reading of the voltmeter? Voltage you have to calculate. Potential difference you have to calculate. Yes. So it is a LCR circuit. ನಾನು ನಿಮ್ಗೆ already ಈಗ LCR circuit ಹೇಳಿದಾಗ ನಾನು ನಿಮ್ಗೆ ಫಾರ್ಮುಲಾ ಹೇಳಿದ್ದೀನಿ. ಹೌದಾ? Yes. So with the help of the triangle, 200. Yes, very good. So if you see the VL and VC is equal to 100. New figure ಅನ್ನು ನೋಡಿದಾಗ you can understand VL is equal to VC is equal to 100 volt ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. And V is equal to 200 volt anta ide. So if I substitute here, there is V is equal to under root of VR square plus VL minus VC whole square. So what is the value here? That is VR square. You keep it as it is. ಮತ್ತೆ V ಅನ್ನ 200 ಅಂತ ತಗೊಳ್ಳಿ. 100 minus 100 is 0. So 0 ಆಗೋದ್ರಿಂದ ಬಿಟ್ಬಿಡಿ. ಕರೆಕ್ಟಾ? Therefore, under root of V square is equal to ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ? You are getting under root of, you are getting it as what? Under root of VR square is equal to, so square ಮತ್ತೆ square root cancel agi, we are left with only VR, that VR is equal to 200 volt. Everybody followed the same step? Yes, completed everyone? Again, we have the next question with respect to the circuit here. So in the series LCR circuit shown the impedance is. So series LCR circuit ಕೊಟ್ಟಿದ್ದಾರೆ. Here you need to calculate the impedance. Z is equal to. So already we have discussed Z is equal to under root of R square plus XL minus XC square. You can calculate the XC and XCL value because you have given with the frequency, the voltage, the H value, the every value is there. D, so quick calculation. Yes. So as I told you already, that is we have the formula Z is equal to. So formula in baratte anta andre, that is Z is equal to under root of R square plus XC minus XL whole square. Aita. So this R square is equal to what? 300 whole square plus XL minus XC. XL minus XC previously ನೀವು calculate ಮಾಡಬೇಕಾಗತ್ತೆ. XL is equal to 2 pi FL ಅಂತ ಬರುತ್ತೆ. So therefore it is 2 into pi into F value. Diagram ಅಲ್ಲಿ ಇದೆ ಇದು 50 upon pi ಅಂತ and it is into L. So pi will get cancelled. This is 100 ohm. Similarly, XC is equal to. So XC is equal to 1 upon omega C. That is equal to 1 upon 2 pi F into C, which is equal to. So if you substitute the values here, you will get it as 500 ohm. ಹಾಗಾದ್ರೆ ಇಲ್ಲೇನಾಗುತ್ತೆ ಬ್ರಾಕೆಟ್ ಒಳಗಡೆ it is 500 minus 100, it's whole square. So 300 square is nothing but 9 ಬರುತ್ತೆ. 3 square 9 ಬರುತ್ತೆ. So it is 9000 plus 5 minus 1, that is 400. 400 is the square. So if you simplify and take it out of the root, you will get it as what? 500 ohm. Yes. All the solution steps are in front of you. Please copy down. Once you have copied down, please tell me. Okay, going for the next question. A circuit containing a 20 ohm resistor and 0.1 microfarad capacitor in series is connected to 230 volt AC supply of angular frequency 100 radian per second. The impedance of the circuit is, what is the impedance of the circuit? Again, Z they are asking, V kottidare, R kottidare, C value is given, omega value is given. Yes. So you can see here the formula is what? Z is equal to under root of R square plus omega, because the formula is what? Z is equal to R square plus XC square anta ide. R square plus XC square, which is equal to R square plus XC anta andre omega into C square irodrinda omega square into C square anta agate. Therefore, we can substitute R is equal to 20 ohm. Here you can see R is equal to 20 ohm the square ide, 20 square. 1 upon omega square into C square. Omega value is given. So, capacitance value is 0.1 microfarad. So, if you convert 10 raised to minus 7 agate, and omega value is given as 100 radian per second. So see the calculation. If you have any doubt, you can ask. The option A is the correct answer. That is 10 to the power of A. So 10 to the power of 5. Yes, completed. Next question. A 0.2 kilo ohm resistor and 15 microfarad capacitor are connected in series to a 220 volt 50 hertz AC source. So frequency is there, voltage is there, capacitance value is there, resistor value is given. The impedance of the circuit is, you have to calculate the impedance. So already I told you how to calculate the impedance. So similar one, see. Please try it yourself, students. D. What about other students? So quick calculation. So how to do this one? That is the impedance Z is equal to what? Under root of R square plus XC square. So XC square is nothing but what? Already you know XC is equal to 1 upon 2 pi FC. Hoda. So frequency is given as 50 hertz. Matte capacitance value 15 into 10 raised to minus 6 farad anta agate. And the resistance kuda nodi, they have given the resistance value as 0.2 into kilo andre 10 raised to 3 ohm anta agate. Check what is the answer. So this is option D. Already steps I have told you. ಯಾರಿಗ್ ಗೊತ್ತಿಲ್ಲ ಕಾಪಿ ಮಾಡ್ಕೊಳ್ಬಹುದು. I'll wait for a minute. Is the next question. As the frequency of an AC circuit increases, the current first increases and then decreases. What combination of the circuit elements is most likely to comprise the circuit? This already it is completed or what? No, that is constructed. Okay. I guess similar question we have discussed, if I'm not wrong. All the three? Yes. So that is impedance, the Z. Option C is the correct answer. Andre circuit alli resistor, inductor, capacitor. All the three we should have. Okay. The next question. Again, the numerical. A circuit consists of a resistance of 10 ohm and a capacitance of 0.1 microfarad. If an alternating EMF of 100 volt, 50 hertz is supplied, the current in the circuit is. So what is the current in the circuit? See what all they have given. It consists of a resistance. So the resistance value is given as 10 ohm. Resistance is given as 10 ohm. The capacitance is given as 0.1 into 10 raised to minus 6 farad. If an alternating EMF, so the EMF value, how much it is given? It is given as 100 volt and the frequency is given as what? 50 hertz. The current in the circuit is. So what is the current in the circuit? A, 3.14. Yes, correct it is. So again same, that is IRMS is equal to ERMS divided by Z. ERMS value is 10, but the Z value 3.2 into 10 raised to 4 agate. So if you simplify 3.14 into 10 raised to minus 3 ampere. You have to calculate first Z. From the Z you can reach the IRMS. Copy down the solution. Okay, students, the next question. 200 volt AC source is fed to a series series LCR circuit having XL is equal to 50 ohm, XC is equal to 50 ohm, and R is equal to 25 ohm. The potential drop across the conductor is. Potential difference across the conductor is. Yes. Here the potential drop is given by IRMS into XL. ಹಾಗಾದ್ರೆ IRMS is equal to VRMS divided by Z. Options are not there. Okay, sorry. Answer is 400 volt. See, answer is 400 volt. So VRMS is given as 200 volt. XL is equal to 50 ohm. XC is equal to 50 ohm. And the R is equal to 25 ohm. Therefore, the impedance is equal to R square plus into bracket XL minus XC whole square. So substitute the values, simplify Z. Once you get the Z, 200 by 25, it is 8 ampere. Completed? Yes, the next question. Completed, everyone? Is the next question. At resonant frequency, the impedance in the series LCR circuit is. So series LCR circuit alli resonance condition alli what happens to the frequency anta kelta idare. Maximum, minimum, zero, infinity. Minimum or maximum it is. It is option B, that is the as at the resonance the conductive and reactive capacitive reactances are equal. So ಎರಡು equal ಇರೋದ್ರಿಂದ the resonance frequency, the impedance in the LCR circuit is less. Yes. The next question. In LCR series circuit is under resources. If Im is the current amplitude, Vm is the voltage amplitude, R is the resistance, Z is the impedance, XL is the inductive reactance, and XC is equal to capacitive reactance. ಅಂದ್ರೆ terms ಯಾವ ರೀತಿಯಾಗಿದೆ ಅದನ್ನು describe ಮಾಡಿದ್ದಾರೆ. Then so ಕೊಟ್ಟಿರೋ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗಿದೆ? The impedance is given by Z is equal to under root of R square plus XL minus XC whole square. So therefore Z is equal to R anta ಹೇಳಿದಾಗ the equation becomes Im is equal to Vm by Z or Vm by R. Yes. The next question. At resonant frequency, the resonant amplitude in series LCR circuit is. Option A, maximum. Yes, option A, maximum is the correct answer. Next question. A resonant frequency of series LCR circuit with L is equal to 2 Henry, C is equal to 32 microfarad, R is equal to 10 ohm is. Resonant frequency you have to calculate. Resonance frequency is equal to 1 upon root of LC. So substitute all the values. Option A is the correct answer, C. Yes, any doubt? Till now, whatever we have discussed, any doubt in that, students? AC chapter is easy once you know the formula. Okay, yes. The next one is the Q factor for a series LCR circuit with L is equal to 2 Henry, C is equal to 32 microfarad, and R is equal to 10 ohm is. Q factor. Yes, already I told you formula, no? See, the Q factor is given by what? Omega L upon omega into L upon R. Option C is the correct answer. So L ಮತ್ತೆ R ಗೊತ್ತಿದೆ. What to do with omega or the resonant frequency? It is 1 divided by root of LC. So 1 divided by root of L into C is 2 into 32 into 10 raised to minus 6. That is nothing but 10 raised to 3 divided by 8, or the quality factor is equal to omega into L divided by R. Yes, copy down. If any doubt is there, please ask. The next question. So you have a figure, LCR circuit is there. The voltage is given as what? 230 volt. The source frequency which drives the circuit in the resonance is, you need to calculate the source frequency. Options are given: 4 hertz, 5 hertz, 6 hertz, 8 hertz. Yes. So last quality factor discuss ಮಾಡಬೇಕಾದ್ರೆ resonant frequency ಅಂತ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. So in the given question, ನೀವು ಬೇಕಾದ್ರೆ question copy ಮಾಡ್ಕೊಳ್ಳಿ. Copy down the question, then I'll tell you the hint. Yes, see. That is the resonant angular frequency is given by what? Omega is equal to 1 upon root of LC. So 1 divided by root of L into C. L is 5 into C is 80 into 10 raised to minus 6. So simplify this, you will get the angular frequency. ಮತ್ತೆ linear frequency ಬೇಕಂತ ಅಂದಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ? That is, we know that. ನೀವು first year ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಾ. The relation between the angular velocity or the angular frequency and the linear frequency is given by, that is omega r is equal to, sorry, Vr is equal to omega r upon 2 pi, or 2 pi is equal 2 pi omega r is equal to 2 pi Vr is equal to omega r, the relation between the linear frequency and the angular frequency. So adanna use ಮಾಡಿ ನಾವಿಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we are calculating the value of Vr. So that is nothing but 50 divided by 2 pi. ಅಂದ್ರೆ 8 hertz ಅಂತ ಬರುತ್ತೆ. Okay students, is completed. One the last question. Okay, so see, step down transformer connected to an AC mains supply of 220 volt is made to operate at 11 volt 44 watt lamp. Ignoring the power losses in the transformer, what is the current in the primary circuit? You need to calculate the current in the primary circuit. The options are 4 ampere, 0.2 ampere, 0.4 ampere and the 2 ampere. What is the current in the primary circuit? Yes, copy down the question. So see here students, the power value is given as how much? 44 watt. 44 watt anta kottidare. The primary source is having the voltage of 220 volt. Matte secondary source voltage estide 11 volt anta ide. So power is equal to Vs into Is. P is equal to 44, which is equal to 11 into Is. Therefore Is is equal to 44 upon 11. That is nothing but 4. And the current in the secondary circuit is how much? It is 4 ampere. Hagadre, the current in the primary cell is, primary circuit is. So now we know that is VP IP is equal to VSIS. Andre VP IP andre primary cell, primary transformer. Okay. So substitute the values. IP is given by what? 11 into 4 divided by 220 ಮಾಡಿದಾಗ IP value 0.2 ampere ಅಂತ ಬರುತ್ತೆ. Okay. Yes. Copy down. So as I told you, time ಕಡಿಮೆ ಇರೋದ್ರಿಂದ on each chapter which will cover all the concepts ಆ ರೀತಿಯ questions ಅನ್ನ select ಮಾಡಿದ್ದಿದೆ. Hope so this completes your alternating current questions. Okay, copy down this solution. One more you take it as a homework. Copy down this. Once it is completed, tell me in the chat box. I'll give you the homework one question. Okay, take it as a homework. An alternating voltage is given as 220 sine of 100 pi t volt is applied to a purely resistive load of 50 ohm. The time taken for the current to rise from half of the peak value to the peak value is. So you need to calculate the time for this. Yes, take it as a homework. Okay, students, copy down. We will meet in the next class. Thank you.